Hi everyone, hope you all doing well. Welcome back to our channel. In this video, I'm going to showcase some of the methods that you can follow to understand what kind of data filtering process you should apply in the data which is getting ingested so that you can save a lot of data ingestion cost in Azure Monitor with the help of DCR, because there are two different types of transformations which are available. The very first one is table level transformation itself, or typically speaking table transformation, and the other one is the actual process of creating a DCR manually and then going ahead and customizing it. Okay, so data filtering strategy is basically a kind of 4-step process that you should follow. Okay, and I'll show you the one which I have already implemented, but I'll break down the entire implementation process so seamlessly that you will be able to replicate that in your environment with some other table as well. Now, the very first step in terms of defining data filtering strategy is to go ahead and check for underscore build size and underscore is build attribute for the events which are getting ingested in a specific table of your log analytics workspace. Okay, so let's take an example of common security log in my scenario, because I will be able to show you a lot of data which I have manually ingested. Okay, so understand that this is my table where data ingestion is happening. Let's say if I go ahead and say top 100. Okay, this is the data which is getting ingested in the common security log table of one of my workspace. Now in your environment, this example can be exceptionally different. You can have any table. You can apply these concepts to practically any table that is receiving data in a log analytics workspace, right? Now understand this, that I'm not going to do anything with the device version when I have to perform any analysis. Okay, this could be any version. And think about it. Let's say if I'm doing a analysis and I found that practically speaking, all the data which is coming for, let's say this particular column is always having same value. Okay, then adding this is basically something which is not going to make sense. Okay, so you can see that the entire each and every entry that's coming over here is showing me the same device version. So assume that for my analysis, I don't need device version to get ingested. Similarly, I don't need device event class ID, because the actual set of information is something that's available in activity type. And let's say if there is a malware which has been plugged, then what is the malware hash? Okay, so basically you have to perform a deep analysis of the data which is getting ingested, in terms of finding that whether the data which is getting ingested is actually useful for you or not. Okay, so let's say if I go ahead and try to project now the build size. Now every entry, practically speaking, that will be available in any of the workspace table will have these two columns defined, which is build size and is billable. Is billable means this will be included in your data ingestion cost. Now there are certain tables where this value will always come false. Let me show you that as well. So let's say if I query security alert, you will see it is something which is not billable. Similarly, if I go ahead and query security incident, that's also not billable. But if I'll go ahead and query device events, it is actually billable. Similarly, common security log is also billable. Syslog is also billable. So whether you have to find that which log entry is actually billable when it comes to log analytics workspace, you can just go ahead and use these two columns to check their state. Okay, now see, my build size as of now for common security log is 737. Okay, now I have to look up for the attributes which are not required for any kind of analysis. See, I am explaining all the examples related to security, but you could be using this for any other use case as well. So fundamentally, you should understand how you should remove the unwanted data which is getting ingested because there is a default schema. Now, whenever you are ingesting a specific log type, let's say that has 50 attributes and they all are getting ingested, but fundamentally you don't need those 50 attributes. You only need, let's say, 15 or 20. Then with the help of DCR, you can actually perform all this advanced configuration to save a lot of data ingestion cost. And I'll give you real-time examples. Okay. So now let's say my build size is around 737 for this particular entry. Okay. Now let's say I'll copy this. Okay. Query into a new tab or into a new instance. Okay. Now here, I'm just going to remove the entries which I practically don't need. And based on my analysis, okay, these are, let's say, 5 or 6 attributes which I practically don't need. So let's say if I remove this, yeah, now you can see I'm getting the list. I'm getting the same event here. However, this is not having these set of columns. Okay. Now you might be thinking that I'm just using a specific function over here to remove all these, columns from getting presented here. You are absolutely right. But let me tell you something. This is the same process that you have to do when it comes to populating a specific KQL query in the transformation section. So if you have seen the last video where I was showing this transform KQL, and let's say if I copy this section which I have applied to one of the rules, you will be able to relate. You can see the only difference here is this particular section, which is source. Rest, everything is same. This process of deciding which columns you have to remove is fundamentally same. Okay. So let's say if I remove all this right now, and now the main part, I want to analyze that when I'm removing all these different columns, is there any benefit that I'm getting? Okay. So let's say I want to know now the actual data ingestion size. So I will say estimate data ingestion size, and then I'll click on run, and you can see it is showing me 887 as of now. And here it was how much? 737. Now the reason behind that is because it is actually querying all the different attributes as well, which are, let's say, related to the default schema, which a SIEM solution had. So I'll go ahead and remove resource ID, and then I will also remove underscore subscription ID. I will remove tenant ID, and then let's say click on run. You can see it is now showing me 707. Okay. Now let's say if I go ahead, and there is one more specific attribute, which is generated by, or let's say which is available or gets populated by Azure. Just give me a minute. Let me quickly check that as well. So I'll show you that particular part. And I think it was somewhere, yeah, type. Okay. So let's say I also remove type. Let's keep tenant ID. Let's just remove type. Okay. So yeah, you can see it's now showing me 726 as estimated build size for this particular event. I'm inside the same table. I'm not making any change. I'm just projecting away certain columns, and you can see the size has been reduced. It's here 737, and here if I'll go ahead and show you, it shows 726. Now, however, There is a lot of customization which happens under the hood, and let me show you that as well. So this is my another table, where all the customization has been done when it comes to adding that custom KQL in the DCR itself. And here, if I'll go ahead and show you the build size, you can see it's around 551, 541, and you can see it's not same, or let's say the build size itself has been reduced. And however, if I write the same query here, let's say top 1 by time generated, and here also I write the same query, top 1 by time generated, you can see the difference, okay, in terms of the data which is getting ingested. Yeah, one more very important attribute which I have not removed here was additional extension. Okay, no, it's already there. Yeah, so it's fine. So my intent here is to make you understand that you have to perform an analysis in terms of making sure that you are eliminating the right set of columns which are practically not required. Okay, so let's use one more example of, let's say, security events, okay, which are coming from Windows machine. Let's run it for last 7 days. And now let's try to understand that what exactly, or if there is practically anything which is not required. So you can fundamentally understand that if security event is coming, for sure you don't need channel, right? You don't need channel. You already know it's a security event, and this information is not going to help you with any security analysis. Okay, now we can keep event data, we can keep all these additional infos if required, if you think that this is something which can help you with any kind of analysis in the future. And when you keep on scrolling and just take a look on all these different attributes which are coming over here, and then just see that if there is anything which you can avoid, practically speaking, and then you can just add them in the DCR itself. So let's say I can just go ahead and remove this event level name. Okay, now here I'm saying project. Okay, let me cancel this again, run, and paste this here, and come to event level name. Yeah, process IDs. You can see these are all n number of different attributes, and some of them will have values, some of them will not have values. Anyways, the value, if there is any let's say value which is empty, practically speaking, or which is null, then obviously it's not charged. Okay, so let's say virtual account is also something which I don't need practically. Okay, and then here let's say OP code. Okay, keywords, and then I can say, again, you can see type, right? And that's it for now. Just assume this is all that you want to remove. Okay, so now I'm going to say project away all these, and then show me the size. Okay, so I'll say summarize total, and then just estimate the size, calculating all the columns. Okay, and here I will say, let's say top 1 by time generated. Okay, and I'll click on run, and you can see it showing me 932. Okay, now assume that you are not removing any of these. Okay, and then you're trying to estimate the size of a specific column. It's around 981. See, these values are in bytes. However, for one single record, it's not going to, you will not be able to understand the difference which which it is going to make. But the moment we talk about data ingestion, where the daily data ingestion is around 100 GB, you can save around 25% of data ingestion by just customizing one single table. Okay, and let me show you this as well. Okay, so this is my table where I have applied certain customization. Okay, and if I try to go ahead and search for, let's say, the build size, here I'm going to say project and I'm saying underscore build size. It's around, yeah, you can see 551 is something that's coming. Let's just take the top one itself by time generated. You can see 551, and here also let's just run the same query. So this is my workspace, Sentinel workspace, where I have applied the KQL transformation KQL. And here if I go ahead and run this, you can see the size difference. Here it will be around 737. Okay, now let me do very basic maths, okay, which is here. So you can think about it. Common security log using default data ingestion is around 737 bytes per record is the build size. Once I have applied data filtering, it's around 551. Again, this is the process that you have to follow. Now just assume these are the number of records which are getting ingested in a day, and your daily data ingestion is around 102 GB. Okay, so if you use this process which I have shown you right now, by just removing the unnecessary attributes from getting ingested itself, you can save around, let's say, 25 GB of data ingestion on a daily basis. This is the percentage, in fact. But if you'll do simple maths, you can understand that this was my data ingestion before customization, and this is after customization. So yeah, you can see around 25 GB of data can be saved from getting ingested. And again, this is just one of the example that I'm showing you right now. Practically speaking, you can go ahead and apply this to any table that exists. Okay, any table, security event, or let's say some other data source which is coming. Now, one more very effective example that I'll show you right away, and that's moreover related to AAD interactive sign-ins. Okay, now think about it, that this is the table which basically creates entry for all the non-interactive sign-ins. Okay, now let's say if I go ahead and say project build size for me, and tell me whether this data is billable or not. Okay, so I'll say is billable. Now think about it. This data is something which is used very rarely. Okay, now think about it. It's why it's not showing me. Okay, by mistake I have done project away. Let me just project this. So you can see the amount of data which is coming for this particular table. Now I want to ask you folks then, that when were the scenarios where you have performed the analysis for this particular table? If there is any one, please comment and let me know. Okay, however, if you integrate Azure AD sign-in logs, you will get the option to ingest all this data. Now assume that you want to keep this data for compliance perspective. Okay, let's be very practical. I want to keep this data, but then there are certain attributes which are fundamentally not required. Okay, so let's say operation version. Okay, but before I go there, let me just show you the build size for the last event, and then we'll perform our data filtering analysis. Okay, and from this, just show me build size. Okay, so this is the last event build size. Now let's go ahead and try to customize this with the analysis that we have done. Okay, so I'll remove this, I'll run this, and let's just see what all we can remove. Okay, so let's say I don't need operation version, let's say, for example. Okay, then let's just scroll right and see, I don't need resource group information, because fundamentally this is the only information which will be available always. You can go ahead and check it. Okay, now I'll just keep on scrolling and see if there is anything else I can get. So here I'm saying autonomous system number. I don't need it. Okay, again, you can go ahead and check. You will not be performing any analysis on this data. Then I'll just keep on scrolling. Is interactive will always be false because it's a non-interactive sign-in logs. And then if I'll scroll it again, let's see if I can get something else which I can remove. Type we can remove. Okay, and I can click on run. Now one more catch. If you'll see the section of columns, there will be so many columns which are not even displayed by default. And this is a scenario, practically speaking, for each and every table that exists. Okay, so make sure you are very much you're looking, practically speaking, everything if you want to save a lot of data ingestion cost. Because at times, this is what I have seen, that there is a certain commitment tier that you have enabled, and if you are reaching that particular threshold, you basically stop ingesting data which is actually required. So don't follow this process, because then it's not a good practice. Okay, so you can see I'm not getting moreover the new columns that I have populated, or practically speaking any data inside them. So let's just run this query now, and then let's just see what is the total of what is the sum of the data that will be available if I remove all these columns. Okay, so I'm saying total and I'm saying sum, estimate, data size, and all the columns. So it's around 2990. Now let's just add this line here and show you how it is getting. Estimated data size is around 3046, 80 interactive sign-in logs, and yeah, you can see 2990. So again, when we talk about millions and billions of records, then this is something which is going to help you save a lot of data ingestion cost. Okay, so the last two steps basically is to create a query with projecting away the attributes which are not required, and then calculate the new data ingestion size. So fundamentally, if I have applied this filter here, then this is what the data ingestion size, and if I'm not applying anything, then this is what the data ingestion size is all about. Okay, and then the last thing is to go ahead and just do a map. I mean, what is the size that is coming before you have applied all the customization? So fundamentally, this is where no customization exists for common security log, and this is where all the customization exists. Perfect. So this is all about knowing how you can apply data filtering strategy for a specific data ingestion type. In the next video, we are going to see how exactly the billing and usage table in Log Analytics workspace can help you with a lot of data ingestion insights. So if you think that this channel is helping you to learn anything new, please feel free to subscribe and share this video with your technical community. Thank you so much. Thanks for your time.